Hey guys, so it is the day before the last pure exam. I mean, imagine it. After this, you don't need to do any more pure maths unless you had to know what you're doing at university. Don't forget about it too quick though, because last year in the stats paper there was an integration by parts question. So don't delete everything from your memory too quickly. Otherwise, it might be coming up in some sort of way in mechanics or statistics. I would love to know in the chat how you guys have found paper one. What did you think of it? What was probably like the hardest question in there? I imagine people are probably going to be saying some of the hardest stuff was, I'm predicting what's going to come up in the chat here. I think they're probably going to be saying the substitution question, integration, of course. And I think they're probably going to be saying the badge question as well, is what I imagine people are going to say. I'm also waiting. No one's even said anything about my new haircut, which obviously is a big week for me, a big week of live streaming and stuff. I thought the chat was going to be flooded with wonderful compliments about my fade, but whatever. That's fine. You're all here for the maths. I get it. Now, if you do want some last minute kind of revision stuff, I talked about this in the previous live stream, but there are £15 tickets available for an in between Pure 1 and Pure 2 session. So if this live stream isn't enough for you and you want to do a bit more revision, you get a 2.5 hour Zoom with me. It's a recording, you get it immediately. And you also get an hour and 45 minutes of me going through questions that are all focused on EdXL paper 2. And I've also made the decision to reduce the prices on my mechanics and stats masterclasses, the aiming for A-star classes that I did, and they're now only £15 as well. So I've only just made those reductions. I think yesterday I did those. So if you like the way that I teach and you've got a spare £15, you think that might actually help me get prepared for those last bits, either for the paper 2 tomorrow, you could probably use it tonight, or for the mechanics and stats stuff, then you've got those as well. And the second thing I wanted to say is this is for further mathematicians, I made an everything to memorize video for further stats that was for members only, but I have now made this public just for this last part of exam season. So if you're doing further stats, you should go and check that out. It's now there for free so that you can have a go through that. So I'm going to talk to you about what we're going to do. If you've been in one of these before, you'll know exactly how this works. I am going to be picking a random integer between 1 and 388 in this case, because there's only 388 slides. The reason there are only 388 slides in this document is because I've removed the questions that I think will not be coming up in paper 2. So really this should be great focus of the sorts of stuff that should be coming up in paper 2. Like I said, if you do want more info on the in-between session that I've done, if you get the £15 tickets for it, they're linked in the description, as is this PDF here. You can get it immediately and you can just start working on it tonight. All of the information comes in the confirmation email and you can just start using it. So let's just get started with some of this that we have here. Oh, someone said, where can we find the document with the removed questions? I haven't uploaded this one yet. I haven't removed the questions in a really perfect kind of way, but I can upload this afterwards and I'll add it to the description of the video as well. So I'm going to see how many questions we can get through in this live stream. And we're going to pick, to begin with, I mean, if anything is too easy, I'm going to make the executive decision to say this is too easy. And the reason I'm going to try and do random numbers is I just don't want to be too prepared for the questions that come up. Okay, so it was going to be a circles question. I tell you what, let's just do this for a nice warm-up kind of question on circles, because I feel pretty sure that circles are going to be coming up, okay? So it says here, a circle with center -2, 6 passes through the point 10, 1. Show that the circle also passes through the point, 10, 11 it said. Show that it also passes through the point 10, 1 that we've got here. Okay, well, we know a couple of things about this. We know the center. So immediately I know that we have a -2, 6. And we know that it passes through the point 10, 11. So I think one of the first things I'm going to try and do for this is actually just to find out the radius. Because if I can find out the radius, then I can come up with the equation of the circle, and then I can show that the other point lies on there, okay? So the radius is going to be the distance between these 2 points. Now, when I do this, I literally just look at the two numbers and I just say, what's the gap between them? So the gap between -2 and 10 is 12. You can either think of it as a positive or a negative, but it doesn't matter because it's going to get squared anyway. And the gap between the 6 and the 11 is a 5. So we have a 5 squared plus a 12 squared. Now, I'm that kind of lame mathematician that knows the answer to this because it's a Pythag triple. And if you know it's a Pythag triple as well, I'm not going to call you a lame mathematician. I'm going to say that you are a brilliant mathematician. I don't know why I'm putting myself down like that. Of course, this is a Pythagorean triple. The square root of 12 squared plus 5 squared is 13. So we now actually have the equation of the circle. And the equation of our circle is, using our standard form with the center here, we would have our x plus 2 squared plus our y minus 6 squared is equal to the radius squared, and 13 squared is 169. So all we need to do is show that it also passes through the point 10, 1. So we will check with x equals 10 and y equals 1. So if I substitute in, I'll be a bit extra and show what I'm doing. I get a 10 plus 2 squared plus a 1 minus 6 squared. So that's a 12 squared plus 5 squared, which is 169. So I'll just do a little conclusion sentence and just say, hence, 10, 1 is also on C. And then it says the tangent to the circle at the point 10, 11 meets the y-axis at P, and the tangent to the circle at 10, 1 meets the y-axis at the point Q. Show the distance PQ is 58, explaining your method carefully. Now, this is where like a diagram can just help, even if it's just not a very accurate diagram. But if we have a circle and we're talking about a tangent at one point, oh my God, that's the worst tangent I could have possibly drawn. I can't leave that on the screen. I'm going to have a circle. There's going to be a tangent at one point on the circle and another tangent somewhere else. And look how inaccurate my diagram is. It's literally just to visualize what's going on. It doesn't have anything to do with things being in the correct places. The main thing that we should remember is that the tangent and the radius are perpendicular to each other. So my little method to do for this question, and this can often be quite useful for this, is to write a little list of stuff that needs doing. So I'm going to try and find the tangents. I will find the tangents equations. After I found the tangents equations, it's talking about where it crosses the y-axis. So I will make x equal 0. And then my last thing is I can find the distance PQ. But in order to find the tangent equations, I think what I need to do is to find, is it tangents? Yeah, it is. I think I need to find the equations of, I need to find the gradients of the radiuses as well. So I'm going to start off by finding the m of the radius. And because they are normal to each other, I will then take the negative reciprocal for the gradient. So I've got a little to-do list of things that I'm going to do in this question, if I can sort of just about leave it on that page. And I'm probably going to do this on a fresh piece so that I can make sure I'm going to get all this done. I'll keep coming back to that to-do list. So our center was minus 2, 6, and our first point we're going to look at it as is 10, 11. So I'll begin by finding the gradient here. I'll do the change in y, so I'll do the 11 minus the 6 over the change in x, which is the 10 minus minus 2, which is a 10 plus 2. So that is a 5 over 12. So I'm going to take the gradient now of the perpendicular. This little symbol I use is just to say perpendicular. It's the negative reciprocal, which is minus 12 over 5 like this. So now I will do my equation of the tangent, and that tangent is going through the point 10, 11. So I will do y minus y1, which is 11, equals m brackets x minus x1. And do you remember we said on the to-do list, after we've done this, we find the gradient of the radius, we take the negative reciprocal for the gradient of the tangent, we find the tangent equation, and then we make x equals 0 to find out where it crosses the y-axis. So if x is 0, we would get y minus 11 equals minus 12 over 5 times by minus 10. So we can figure out what y is. So I'm going to do minus 12 over 5 times minus 10 plus 11, and we get that y is 35. So I'm literally just going to repeat that whole process, but I'm just going to do it with different coordinates. And the different coordinates this time, I think it's a 10 and a 1. So the gradient is the change in y, I'll do the 1 minus the 6 over the 10 minus minus 2, which is the 10 plus 2. So we get minus 5 over 12, okay? So when I take the gradient of the perpendicular, we're going to get the reciprocal, which is 12 over 5. So my equation of the tangent is y minus 1 this time equals m brackets x minus 10. And I'm going to do the same thing of just making x equals 0. So y, just going off the page a little bit. So y is 12/5 of minus 10 plus 1. So on my calculator, I'll do 12/5 times by minus 10 plus 1, which is minus 23. So if you think about what's actually happening on the diagram here, we've got the y-axis and the x-axis. We've said that one of them is crossing up here at 35. The other one is crossing down here at minus 23. So I'm going to see if I can squeeze it on the page. I will say, hence, the distance PQ is equal to 23 plus 35, which is 58 for this question. So although it's an AS question, I actually do think it's pretty demanding with the number of steps that were required. And I think it's useful to try and like give yourself a little list if you're in the middle of a question that feels like there's a lot to do. The questions I'm talking about that usually have a lot to do tend to be the coordinate geometry kinds of questions. Those tend to be the most kind of common ones. So let's see what else we're going to pick as a random integer. We'll do a random integer between 1 and 388. I will make sure we get some really challenging questions in today's live stream. So we're going to have a look at 151 and see what we've got for this. Definitely going to be a different topic to circles. 151. And we're on some integration. Should we do a much harder integration though? This looks like an AS kind of one. It looks kind of similar to something we've done. So if I just pick one more random number, I'm going to go for a higher number this time. We've got 364, if you see that. So we'll do 364. I pick a random number and then I always want to do it my own way. Perfect. I don't think we can get a better question than this for what I think could be coming up in paper 2. I think this could be something that could be an absolute classic for something that would be coming up in this paper. So we've got some parametric equations here, and it says the curve shown in figure 3 has parametric equations x equals 6 sine t and y equals 5 sine 2t. And they've crucially told us that the domain for t is between 0 and pi over 2 that we've got here. Now, hopefully, I'm hoping parametrics will come up. Maybe you're not, but I'm hoping that they will do because I've done quite a lot of preparation for this. So we're going to start off by trying to show what the area of R is, that the area is going to be that thing. Okay, well, I want to check something. And this is where sometimes people are going to be like, why are you checking that? And it's because sometimes it might be different. So even if it doesn't help us for this question, it might help us for a question coming up. So the first thing I want to do is just to double check what these limits here are going to be, but what those limits are going to be in terms of t, because you normally put the limit here at the bottom and this one at the top. So I just want to double check, what is this bit here? What is t going to be equal to? Well, it's pretty obvious to see that when t is equal to 0, x would be equal to 0 and y is equal to 0. So this must be that t is equal to 0, which means that this end might be t equals pi over 2. Now, the reason I've said this is because it's possible we might have had it where t was pi over 2 here and t was 0, in which case you would put the pi over 2 on the bottom and the 0 at the top, whereas the way we're going to be doing it for our question is the normal way where you have the 0 and the pi over 2. But I'm hoping somebody's going to tell me in the chat if I wanted to go from the red one, if I wanted to make the limits come back to the normal way, what could I possibly do to switch the limits around, just in case you've never seen this concept of switching limits before? I can negate it. And I've just caught in the chat, someone said about the previous question, why did I take the negative reciprocal in the previous question? It's because the radius and the tangent of a circle were perpendicular to each other, even though I was finding a tangent. So this doesn't actually apply in our question, by the way. This doesn't apply in our question because the limits are the expected way around, but I'm trying to prepare you for what could come up in tomorrow's exam. Now, normally, to help you try and remember how you find integration, we normally integrate y with respect to x, and we would make the limits have x limits. But because we're doing this in a t question, we change it. So we add a dt, and we add a dt, and we make sure that the limits are in terms of t. And those limits are just going to be between 0 and pi over 2 for this bit. So we're going to just differentiate x and multiply it by y. Looks like we're going to be doing some trig in this question, quite a lot of trig. So when I differentiate x, dx dt, I would get 6 sine t goes to 6 cos t. So if I was going to find out the area, it's the integral from 0 to pi over 2 of y, which is 5 sine 2t. And I want you to tell me what I need to do to the sine 2t in order to get it to the thing that we're aiming for. So I'll be looking for that in the chat in just a second. And that's going to multiply by dx dt, which is 6 cos t. And we still have the dt that goes with that part. So I've got the 5 and the 6, which is probably going to be useful for me. So I'm going to say it's between the 0 and the pi over 2. And people are already telling me in the chat that it's the double angle. So I'm going to change the sine 2t. I've got the 5 times the 6, which is the 30. The sine 2t is 2 sine t cos t, and we have the cos t. I mean, this is only a 3 marker, so this isn't super tricky at this stage. So we have the 30 times the 2, which is our 60, and then we have our sine t, cos squared t, dt. And then it says for part 2 of the question, hence show by algebraic integration that the area of R is exactly 20. Now, I'd be really interested to know what kinds of things people are expecting to have to do to integrate this particular expression that we've got here, because this is different to paper 1's one. The paper 1 integration had something where we had to integrate sine squared that was by itself, and we had to do something a little bit different for that part. Good. This is going to be a reverse chain rule because we can see, I sort of talk about this in my integration masterclass masterclass. I actually reduced the price on the integration masterclass. That's only a tenner. Sine squared is to do with the derivative of the cos squared that we've got then. So I'm going to just go straight into continuing with this. And I'm saying, okay, well, I think because it's a cos squared here, I think it's going to have come from a cos cubed t. And then what you might like to do to check this somewhere else is you might like to say, I'm going to just differentiate cos cubed t, and I'm going to see how it's different to what we've got here. If I differentiated it, I would pull the power down, I would reduce the power by 1, and I would multiply by the derivative of cos t, which is minus sine t that we've got here. So I don't want it to have a minus 3 at the front. I want it to have a 60. So I need to add something into the front of this. I need to add a minus to get rid of the minus. And to get from 3 to a 60, there needs to be a 20, and that's going between 0 and pi over 2. Now, someone has said, can I do this with integration by parts? No, this is not a good setup for integration by parts. Integration by parts is usually where you have like an algebraic term and an exponential term, or you have like a trig term with an exponential term, or trig with algebraic. This is two trig things together, which makes us think that we should be doing it in a different way. Okay, shouldn't be doing it with by parts. You could also do this with a substitution. I'm saying that in the chat as well. So when I continue, I will just substitute in. So I'm going to get minus 20, and then I'm going to have cos of pi over 2 all cubed. And then I'm going to be subtracting minus 20 cos of 0 all cubed. Now, cos of pi over 2 is just 0, so that's just a 0. And this just becomes a plus 20, so we get that 20 part that goes with that question there. And then we get something strange in this question. I think people would probably be put off just by the look of this one, and I know I certainly am. So it says part of the curve is used to model the profile of a small dam, shown shaded in figure 4 that we've got here. Using the model and given that x and y are in meters, the vertical wall of the dam is 4.2 meters high. There is a horizontal walkway of width mn at the top of the dam. Calculate the width of the walkway that we've got here. Okay, well, let's go back to this diagram for a second. They have just said that the vertical wall of the dam is 4.2 meters high. So I know that there's a point here which is 4.2 meters high, and I know that it's this part as well. So I can say at this particular value, the y value is 4.2. And I think that's my starting point. If I can find out the two values of t that correspond to that y value of 4.2, I think that might help me to find out, therefore, what the x values are, and then I can find out the width between those parts that we've got there, okay? Now, I just get a new page. I saw someone asked about the integration masterclass, which is the one that's £10. You get all the materials immediately, and it just is going through loads of integration stuff. If anybody's been to my classes and they liked them, please tell everyone in the chat that you thought they were useful, especially if you've been to any of the ones that you think are going to help us for this exam. So our strategy for this is we're going to be looking at the 4.2 for the y coordinate. So I'm going to solve this equation. This is great revision for trig equations too. So our y is 4.2 and y is 5 sine 2t. And remember, t is only between 0 and pi over 2. So 4.2 is equal to 5 sine 2t. So I'm going to do 4.2 divided by 5, which is 0.84. 0.84. Worth noting that it had to be between minus 1 and 1, didn't it? It had to be. So I'm going to do the inverse sine of, and I'm going to be in radians mode. You probably can't see that on my calculator, but you must be in radians mode anytime you're doing calculus and trigonometry. I'll do the inverse sine of 0.84, which is 0.9972. Okay, that's not bad. So I'm going to have to half that in just a second. So I get that my 2t is 0.997283. That's one of them. And then my other answer for trigonometry, for sine, excuse me, is to do pi minus the answer on my calculator. So if I do pi minus the answer that I've got, I get my second one, which is 2.144309. So my values of t are going to be these ones halved. While I've got that one on my calculator, I shall half it, and I get 1.0721547 like this. And then I don't think it wanted the exact value, so I'm not worrying about exact values for any of this kind of stuff, okay? So I shall do now, let me just quickly times that by 2 and do pi minus the answer to get back to that previous one. I'm going to half that too, and I get 0.4986416 like this. So I've now got the values of t that are at these two pinky points that I've got here. I just want to find out the x coordinates and then subtract them from each other, okay? So I'm going to say that the x is 6 sine t, So that's just going to be finding out this first one here. I've already got it in my calculator, so I will do the sign of the answer and times it by 6. And I've got 2.86939, just a few decimal places. And if I do it again, but using this one, I shall do 6 sine of 1.0721547, and we get that x is 5.2693. So this means that the mn, the length of that walkway that we've got, is going to be these two things subtracted. So it's my 5.26 subtract my 2.869 like this, 2.86939, and we'll go with 3 significant figures. And look how we feel like we definitely have the right answer. When we see 2.4 and then loads of zeros, that feels like we've got the right answer. So I'm going to go with 2.40 meters to 3 significant figures. And this is where I hope, because no one's been telling me in the chat that I've done anything wrong, I hope that when I check the mark scheme, I've got this right. So we do have the 2.04, the 2.40 meters, and the previous part of the question, we knew that that was going to be correct anyway, didn't we? So let's pick another random integer. In fact, let me just have a quick look at the chat and see if there's anything I'm missing in the chat here. This was where I substituted in. I substituted in here that t was 1.07215, and here I subbed in that t was 0.4986, like that. Okay. Any other questions that I'm seeing there? It looks scary, this question. I don't think it's actually, I don't think this question is too hard, to be honest. Okay, let's pick another random integer. The people who try and say like the funny things in the chat, I'm like, why aren't you just here to revise? It's so strange to me. It's the day before your A level. So we've got the 1, 2, 3, 8, 8 that we've got. A random number. We're picking number 1. We're not going to do number 1. No way. 43. Let's see it. It could be something interesting. If not, we'll just go deep into some of the other A2 kind of stuff. But let's see what we've got. And that's another circle. Okay, 196. Let's try that. 196. Ooh, great. That one I'm not going to be able to do because of the graph, because I need to interpret some things from the graph. But I'm going to pick one that's really similar to this because I do think that it's going to be coming up. So I'm going to find something that will remind me of that one. Let's do looking for, actually we can do this one that's here, you know, this one will be fine. In fact, I want one that's the most classic kind that always comes up, this kind of stuff. This is the exact kind of question that I'm looking for us to do for this. Okay, so let's have a look at this one. We've barely had any exponentials and logarithms, so I'm really expecting to see quite a lot in this paper, at least one question. I think there's probably going to be an exponential modeling question similar to this one, I should think. So it says, at time t seconds, a pendulum takes to complete one swing is modeled by the formula t equals a L to the b. Notice when I do an L, I do a curly L because it doesn't look like a 1. And it says where L is the meters of the length of the pendulum and A and B are constants. Show that this relationship can be written in the form, and I've taken logs of everything. So my first step is to take logs, okay? I'm going to begin. So I get log base 10 of 10 equals log base 10 of a L to the b. Now my question is, can I just pull that b down to the front? And if not, why not? So no, you can't. You can't. I'm seeing this coming up. You can't take the b to the front, okay? You cannot take the b to the front for this. And yeah, this is going to be posted afterwards, this live stream. So I'm going to split this. It'll be a log 10a and a log 10 of L to the power of b. But now I can put the b to the front of this part that we've got here. And I was talking to someone about this earlier, but even though we've got exactly what they've written, or almost exactly, for some reason, I just feel like I need to swap it to make it look exactly like the thing in the question. Does anybody do that when they're in the exam? It's like you've got something that's equivalent, but you just feel like you need to make it look even more equivalent to what they've got. So this is the classic kind of part of the question that we have. It says the student carried out an experiment to find the values of the constants a and b, and the student recorded the value of t for different values of L. Figure 3 shows the linear relationship between log base 10L and log base 10T for the student's data, and the straight line passes through the points minus 0.70 and 0.21, 0.45. Using this using this information, find a complete equation for the model in this form. Okay, so let's have a look. We are going to do, what are we going to do here? We're going to find out the equation of this straight line. Now, I'm going to do it with y and x, but afterwards I can switch these things between the different log parts that we've got. So I'm going to find out the gradients. We did some gradient earlier, so I'll do the 0.45 minus the 0 over the 0.21 minus the minus 0.7. So that is 0.45 over 0.91, which is 45 over 91. So I can actually now come up with that equation. It is going to be y minus y1, which is going to be this one I have over here, equals m brackets x minus 0.7, which is 0.7. So y is equal to 45 over 91x. If I times this 45 over 91, I'm going to times it by 0.7, and we get 9 over 26. Now, it's not y and x, is it? If you look on the graph, it's log base 10t instead. So I'm going to replace the y with log base 10t. And it's not x in this question. If you look at it, it's actually log base 10l. So it's log base 10l plus 9 over 26. Now, what we're going to do with this part is we're going to spot the difference between this equation, and we just use it to do some quick comparisons. Well, clearly, that one is the same as that one. And I've clearly got a log base 10 here and a log base 10 of L. So that must mean that B has to be the same as 45 over 91. And it also means that log base 10A has to be the same as 9 over 26. So I'm just going to write this down, that B is 45 over 91, and A, or log base 10A, is 9 over 26. That's a 9, not an A. So that means that A is 10 to the power of 9 over 26. So I'll do on my calculator 10 to the power of 9 over 26, which is, does it want it to anything? It wants each of them to 3 significant figures. So I need to go back. So that's 2.22 to 3 significant figures. They want me to change this to 3 significant figures. So 45 over 91 is 0.495, 0.495 to 3 significant figures. Oh, I'm off the page. Sorry, guys. Did not mean to be off the page like that we had, okay? So it wants us to actually find that complete equation. I'll probably squeeze it down here. So I'll say that t is equal to a, which is 2.22, multiplied by the length, which is L, to the power of 0.495, okay? It says, with reference to the model, interpret the value of the constant A. Now, this is the 2.2 here. People normally say like, oh, it's the initial. But what does that mean in this case? We actually can't do it for an initial for this one. Is this part B? It's part C. So what do we think it's going to be for this? What do we think it's going to be for this part that we have? Isn't it 45? Have I made a mistake somewhere? Did I make a mistake? Oh, I hope I haven't made a mistake for this. If I did, I'll have to quickly figure out like this. Sorry, maybe I did type one of these bits in wrong. 45 over 91 times by 0.7. I hope I didn't type anything in wrong. I'll have a look at the mark scheme in just a second. Yeah, so the answer for that last bit is that it is the time when the length is equal to 1 meter. Okay, it's the time taken for the pendulum of length 1 meter. Now, this probably wouldn't get the mark that I've written down. First of all, the way I wrote time was terrible, but this probably wouldn't get the mark because you'd need to say the full thing. I would say it is the time in seconds taken for the pendulum to do 1 complete swing with L meters that we've got here. Now, I'm really hoping I didn't make some silly error earlier on because I did see some chat and some of that stuff. Oh, no, I didn't. I did get all the stuff right. So people in the chat were making me get paranoid. So notice how they said the time taken for 1 swing of a pendulum of length 1 meters. I was being lazy. Please make sure you give like the fullest kind of sentences for these kinds of questions. So I'll do a random integer. Let's go for the last set. So I'm going to go between 200 and 388 so that we get some quite tricky questions. Let's try 249. I wonder if that's still in exponentials. No, it's sequences and series, which I do think is going to come up in this sigma kind of stuff. So let's rip this off. Let's do another question. Good, about halfway. We're getting through a good number of topics here. So we've got these sequence of numbers. It's question 13, which means it could be challenging. And it says that an plus 1 is equal to k an plus 2 over an. And it says this weird thing at the side, which is that n is a natural number. That just literally means that n is equal to 1, 2, 3, 4, like this kind of stuff. Okay? So let's keep going with this kind of stuff. I've seen some people asking some things about vectors. They don't tend to do the vectors one with two parts. If I have time, I'll see if I can squeeze one of those vector kinds of questions in. So it tells us that the sequence is a periodic sequence of order 3. That means that we're going to have A1, A2, A3, A4. It means that they are coming in groups of 3. So this A4 will be the same as A1. And the A5 term that we have would be the same as the A2 term because it's a periodic sequence, meaning it repeats in those groups of 3 as well, okay? So let's actually just do something. It says that A1 is equal to 2, and it asks us to show something. Well, I don't know how I'm going to get to that quadratic other than just use the formula with the information that they've given. So that's what A1 is equal to. A2 is therefore equal to k lots of A of the previous one, which is an A1, plus 2, divided by A1. Notice how it's an n plus 1, and it's an n, it's a 2, and it's a 1. So for the numerator, I'm going to get k lots of 2 plus 2 divided by 2. So that's 4k over 2, which is 2k. So I've now got that A1 is 2 and A2 is 2k. So A3, because I think this is going to be my most important thing, that A4 is the same thing as A1. So A3 will be k lots of A2 plus 2 over A2, which is k lots of 2k plus 2 over 2k. I might just do a bit of expanding to see what we get. Oh, no, I don't have to really, do I? Because I can actually just cancel that k with this, and then I can divide everything by 2. So instead of it being 2k plus 2, it becomes k plus 1 for A3. And so A4 will be k lots of A3 plus 2 over A3, which is k lots of A3, which is a k plus 1 plus 2, divided by a k plus 1. And I can't do the cancelling like I did in the previous part. So I'm going to just expand these brackets. This is a k times k, which is k squared. And then there's a 1 plus 2, which is a 3. And a 3 times k is 3k. So I get k squared plus 3k over k plus 1. Now I'm going to stop there because I know that A4 is equal to A1. A4 is equal to A1. So I can say that k squared plus 3k over k plus 1 is equal to A1, which is 2. So all that's left is to multiply it by this k plus 1. So k squared plus 3k. When I times these by 2, I get 2k plus 2. And now I can start looking at the quadratic, and I can see that I do have the same thing as them, which is k squared plus k minus 2 is equal to 0. Okay, it says, for this sequence, explain why k cannot be equal to 1. Well, let's just quickly say, well, what would happen if k was equal to 1? So if k is equal to 1, we get that u1 is 2, u2 would be equal to 2 times 1, which is 2, u3 would be equal to, I keep saying u, these are supposed to be a's because we normally use the letter a, but I've switched it to u. Sorry, we normally use the letter u, but it's switched to an a. So A3 is k plus 1, and 1 plus 1 would be 2, and A4 would be 2. So if k is equal to 1, the sequence isn't periodic order 4. 3. Sorry, I don't know why I said 4. It's order 3, isn't it? So that's why k equals 1 was a solution, because it's still true that A1 is equal to A4. That's still true, but it's just happened to be a sequence where all of those things are the same as each other. So what we're going to do now is we're going to go on to the last part of the question, which is to find the exact value of the sum from r equals 1 to 80 of AR. And this literally means do A1 plus A2 plus A3 all the way up to A80. Well, I think we know something from the previous part of the question, right? We know that we can solve this equation, k squared plus k minus 2 equals 0. Either put it in your calculator, or we know it's going to be a k minus 1 and a k plus 2, which means that k has got to be equal to minus 2. Now, if k is equal to minus 2, the sequence we get is that a1 is 2, a2, which we said in this part, is 2k, so it would be minus 4. A3 would be, going back to our previous part, k plus 1. So I'm going to add 1 to our value of k, which is -1. And I don't need to do A4, but we know that A4 is the same as A1. So our sequence goes, it goes 2, -4, -1, 2, -4, -1. It keeps going like that, okay? And so when you add these together, we get this long list of numbers, and we just need to figure out how many of them are going to be included up to 80. So we have a 2, a -4, and a -1. And because it's going up to 80 numbers, we need to figure out how many groups of 3 there are in 80. And 80 over 3 is 26.6 recurring, which means there are 26 groups of these. 26 times 3, that will take me up to A78. So there's also got to be an A79 and an A80, those last ones. So we have 26 multiplied by 2 minus 4 minus 1, which is -3. And these final two terms here, these final two terms are going to be an extra 2 and a -4, because we're doing them in groups of 3. So we're saying there's all these complete groups. We're then going to have an extra 2 and a -4 at the end. So I'll do 26 times -3 plus 2 minus 4, and we get -80 is the sum of that series that we've got. Let's double check that I've done this and not made any mistakes. I do have the -80 for that part that we've got. Now, if you've got any questions, I'm going to take a little pause so that I can drink some of my water and see if there are any other things in here. So people are asking for some harder questions. I will be doing some as well. This person asking about my further mechanics paper, I've done a reaction, but I just did it as a short instead because I didn't think everybody's going to want to see that. To Toby, I don't think that there's going to be any of those arithmetic series proofs in the geometric one. They did that a couple of years ago. I'd be surprised if I saw that again. Let's have a think. What other kind of things we're asking for? What's the hardest exam? I think hardest exam was probably the 2022 was not good. Let's do some vectors. I think people are talking about the vectors kind of stuff here. And people are asking about decision 1 and decision 2. I don't have classes on those this year. I'll try and do that in the future, but that's not going to be helpful for you guys. I don't think there'll be geometric sequences. We've already had a geometric sequence. I imagine it will be sigma notation, and I also imagine that it's going to be arithmetic. They don't tend to like repeating these things. Let's see if I can find an interesting vectors question that we can do. So they tend not to be that crazy, these questions. Let's just dive in with this one. Let's get ourselves warmed up with a question that looks like this, because there's some good things that we can talk about. If it is a proofy kind of one, it tends to not be that many marks either. So let's just warm up with this. I like to, as soon as I see them as a position vector, I like to write them down like this. So I have my 4, my -3, and my 5. My B vector is, notice how there's no I here. They're really sneaky. So there's no I, there's 4j, and there's 6k. And they will accept you do them as column vectors like this. And C is -16p and 10 like this, okay? So let's just go straight in with part A of the question. It says, given that A, B, and C lie on a straight line, find the value of P. Now, if they lie on a straight line, let's just think about these 3 points that we've got. We don't know how spread out they are, but I know something about these vectors. I can say that the vector between A and B has got to be some multiple of the vector between A and C. I know that they can scale because they're going in the same direction as each other. So I'm just going to figure out what AB is equal to first of all, because that's one I can just find out the numbers for sure. So AB is, I don't know if you know this shortcut, but when you do AB, you do the second letter minus the first letter, so you get B minus A. So it's going to be the 0, 4, 6 minus the 4 plus the 3 and minus the 5. So it's -4, 7, and 1. And now I'll work out the vector AC. You didn't have to do AC. If you wanted to, you could do BC, but I'm just going to do them with AC. So it's going to be the C vector minus the A vector. AC is the C minus the A. So it's -16p and 10. I'm going to -4 plus 3 and -5. And we get here -20p plus 3 and 5. So look at the relationship between these two vectors that we've got here. It has all been multiplied by 5. The -4 multiplies to 5 to -20, and the 1 multiplies by 5. So that would just mean that the p plus 3 that we have is equal to 7 times 5. So p is equal to 35 minus 3, which is 32 that we have for this bit. So this tends to be the way that vectors have been coming up over the last few years. I haven't seen them coming up in the sort of geometric ones for a long time. So I don't know if it will be in tomorrow's paper or not. It then says the line segment OB is extended to a point D so that CD is parallel to OA. Interesting. So when we're talking about these as different vectors, we've got some kind of other origin, okay? We had the vector A, the vector B, and we had the vector C. And it's now saying that the line segment OB is being extended to a point D so that CD is parallel to OA. So there's going to be somewhere over here is a point D so that the vector between C and D is parallel to this one. And we know some other things about CD. Sorry, we know some other thing about the point OD that we've got from here to here. It's the same as the B vector, but scaled. So the OB vector, if we scale it by something by mu, that is what the OD vector is going to be equal to. Now, I'm going to have to rip this page so that I have some more space to kind of work on for this, and then I can keep going up and down. So this position vector for D, or OD, is the B vector, but it's being scaled. So it would be a 0, a 4 mu, and a 6 mu. And we know that CD is parallel to OA. So I'm going to figure out what CD is equal to, which is the D vector minus the C vector. The D vector is 0, 4 mu, and 6 mu. And I'm going to subtract the C vector, which becomes a plus 16, a minus P, P was 32, and a minus 10 that we've got here. So it is 16, 4 mu minus 32, and 6 mu minus 10. Now, I know that CD is parallel to OA, which is the same thing as A. In other words, CD is a different multiple of the A vector that we've got. So we just need to do a bit of a comparison now between the 16, the 4 mu minus 32, and the 6 mu minus 10. I'm going to compare that to the A vector. And the A vector is the 4, the minus 3, and the 5. So doing a bit of a comparison here, it looks like to go from this vector to this vector, we are multiplying it by 4. 4 times 4 is 16. So this must mean that 4 mu minus 32 has got to be equal to the minus 3 times 4, which is minus 12. So I'll just solve that equation by doing minus 12 plus 32, divide it by 4. So mu is equal to 5. We need to just find out what is the length of this vector that we've got. So D is equal to, with mu as 5, 0, 20, 30, which means the magnitude of that vector is the square root of all these things squared and added. And I'm going to go through the method of this question again because I think this is a challenging one. So it's a 20 squared and a 30 squared, and we get the square root of 20 squared plus 30 squared, and it wants us a simplified surd, which is 10 root 13. Now, before I go through the method, again, just to kind of highlight some of these things that we've done, let's just double check I have got it right. So we do have the 10 root 13 for this. I'll leave the mark scheme up. So actually, I won't leave the mark scheme up because I want to discuss the question. So what we did in this question is it said the line segment OB is extended to a point D so that CD is parallel to OA. So the position vector of D was the same as the B vector, but it had been scaled by mu, which meant it was parallel to that B. It was in that same direction. It's continuing along like this. Then what I did is I found out the CD vector by doing D minus C to come up with this. And I knew that CD was parallel to OA, which meant that this vector was a multiple of this vector. This technically should have a little t in front of it to show that it was t times bigger. So it's multiplying by 4, which allowed me to find out what mu was equal to, and then find out the length of D. I don't see why this is 3 marks. Maybe there was a quicker way I could have done this bit. Now, I want you to just tell me in the chat whether you think we should be going for whether we should be going for an integration question, maybe something to do with integration by parts, or something different. I think probably integration by parts is something I would like to do. I'm going to do an integration by parts, but I'm going to be looking in the chat now for what stuff you'd like me to be doing afterwards. Okay, I want to make sure that I definitely cover an integration by parts question because I feel pretty sure that it's going to be coming up, and I'm looking for one in particular that I think could be a good one. Yes, we're going to do this one. Okay, I'm not going to do part A, which is the trapezium rule for this, but I am going to do part B, And then we've got some stuff with some integration by parts. I'm seeing people saying implicit, great suggestion. We can do some implicit for this. Shall we just do the whole of this question? No, I think we're just going to, we know how to do part A. We know how to do the trapezium rule. The area is approximately equal to a half of the height. We do the first plus the last plus two lots of the middle terms. And you put it in your calculator and then you press equals. Okay, so I'm not going to actually go through that. So part B of the question is where things get interesting because it says we're actually going to want to integrate ln of x squared, and that is between a 2 and a 4 with respect to x. How do you integrate ln x? What do you do to integrate ln x, which will give me a chance to, again, have some water. And then we can try a trig question next. I think that's a really good idea, Azim. You've got to do by parts. People don't actually realize this, or people often don't realize this. You've got to do it with parts. I don't mind stuff in the chat as long as it's not offensive. I don't mind stuff in the chat. Like, I'm happy seeing people celebrating with flags or whatever they want to celebrate with. We just don't need silliness in here. So we're going to go with parts, okay? So u in this case, ln always takes priority for u. So u is going to be ln x squared, which means that v dash in this case is 1. Effectively, there's like a 1 multiplied by ln x that we've got here. So I'm going to say that v dash is 1, which means I can integrate that and I get x. Now I'm going to have to differentiate ln x squared. This seems weird, but I've just got something squared. You pull the power down, you reduce the power by 1, and then you multiply by 1 over x, because the derivative of ln x is 1 over x, okay? So when we put this all together with our formula, I always see it as, I don't know why I keep talking about this thing like a picnic table, but I have already used this branch in the question. The next thing I use is this part, which is these two things multiplied, which is my x ln x squared. And then my last thing is to subtract the integral of these things. So I'm going to be subtracting now the integral of 2 ln x times by 1 over x times by x dx, and that's between 2 and 4 that we've got. And this cancels. So I'm now actually just left with an x ln x squared minus the integral between 2 and 4 of 2 ln x dx. Now, yes, this should technically have some limits around it, so I'm going to be extra and put them in right now. And I'm now going to do integration by parts again for this. U is going to be 2 ln x. Okay, you can just about see I squeezed the 2 in there. When I differentiate that, I get 2 over x. V dash is 1, like it was before, and V is therefore equal to x, okay? So I'm going to continue with this. I've already used this. The next thing I'm going to get, as I put this all together, is I'm going to be subtracting all of this thing. So it's going to be these two things, which is 2x ln x, and then I'm going to be subtracting the integral of these two things multiplied. 2 over x times x is just 2. And that is between 2 and 4. And again, this should have, technically, the 2 and 4. So I'm actually going to go into one giant long square bracket for this. We have x ln x squared. I'm going to say this is a minus, so I'm going to say a minus 2x ln x. And then this last part would integrate to 2x, a minus 2x, but it becomes a plus. So we get a plus 2x, and that's between 2 and 4 that we've got here, okay? So let's sub in 4. I get 4 ln 4 squared minus 2 times 4, that's 8 ln 4, plus 2 times 4, which is 8. And from that, I'm going to be subtracting 2 substituted in, which is 2 ln 2 squared, 2 ln 2 squared, minus 4 ln 2 plus 4, and that's all in brackets like this. So there's now some interesting bits of manipulation that needs to go on here, because the final answer is in terms of ln2. So you need to know one final thing. Let's use another color I've not used yet. I'm going to just remind myself of the relationship between ln4 and ln2. Well, ln4 is ln2 squared And you can, oh, it's just off the page. I'll pull that 2 down, so I get 2 ln 2. So anywhere I see an ln 4, I can replace that with this. So that's 4, 2 ln 2 squared, minus 8 times 2 ln 2, which is 16 ln 2, plus 8, minus 2 ln 2 squared, plus 4 ln 2, because the negative and the negative, and the minus 4. So 2 ln 2 squared would be a 4 ln 2 squared times 4. So that's 16 ln 2 squared. I've also got a minus 2 ln 2 squared from here. Minus 16 ln 2 plus 4 ln 2 is minus 12 ln 2, and 8 minus 4 is 4. So my final answer is 14 ln 2 squared minus 12 ln 2 plus 4. I mean, there's no surprise that that's like a really hard question for this kind of stuff. Let's just double check and see if I have got this right. So we have the 14 ln 2 squared minus the 12 ln 2 plus the 4 that we've got. So excellent question for this session to have come up like this, because not only have we looked at integration by parts with ln, there's been some really crazy substitution, and we've got this idea of forcing you to have your final answer in a particular form. You may need to do some of these kinds of things that we have here, okay? So you could use the DI method for this. However, I have actually not seen the DI method in a mark scheme for the British A-level. I have seen it in mark schemes for the international A-level. People are asking about trigonometry, and I think we're going to do some trigonometry. So let's just go and see in this section. So from 273, I was going to do implicit, but we'll go from 273 to 298. Oh, no, 273 to 289. So random integer, 273, 289. Syntax error because I have not put a comma, have I? Silly me. 276. Oh, I don't think that looks hard. I don't think that looks hard. 274. Yeah, let's do this. Let's do this. This looks like a nice kind of one for us to start off with. Okay. We have something that looks quite innocent. I wonder if it will stay as innocent as it does here. Some people think, do I think DI will be added to the mark scheme? I actually think it probably will be added to the mark scheme if it comes up with an integration by parts that you need to do twice. So we have a choice here. What do you think we should start on, the left-hand side or the right-hand side? Left-hand side or right-hand side? Yep, fantastic. I would do left-hand side as well. It just is easier. If you ever have two separate things, it's easier to combine these together. And listen, guys, we're not going to be able to do everything in one of these sessions. You know, you're probably going to need to work on some stuff yourself as well. So it's fine. You know, if we don't get through it all now, you can always do the extra session that I've provided as well. So tan theta, I probably am going to put this all in terms of sine and cos. So tan is sine theta over cos theta. Cot theta is cos theta over sine theta. And then when you have them written like this, by the way, you should aim to do these triple lines. If you don't get penalized though. So don't worry about it. I'm going to do a common denominator. And that common denominator is obviously going to be a sine theta cos theta. I just prefer the sine theta part first. So these are going to get added together. So we have sine squared theta and a cos squared theta. Obviously, this needs to be multiplied by sine and this needs to be multiplied by cos. And we know that sine squared plus cos squared is 1. So we get 1 over sine theta cos theta. And then if you look at the thing we're aiming for, we've got the 2 cosec 2 theta. So if you don't have this memorized, guys, what are you doing? Sine 2 theta is 2 sine theta cos theta. So if I half it, I get that sine 2 theta is sine theta cos theta, so which means I can now replace the denominator with a half sine 2 theta. So 1 divided by the half, 1 divided by a half is 2, and 1 over sine 2 theta is cosec 2 theta, like this. And so then it says, hence explain why the equation does not have any real solutions. I hope we'll be able to fit another question in because this was quite a nice short one. I'm sorry this probably wasn't the hardest one that I could have found. So if we're looking for tan theta plus cot theta being equal to 1, I can replace this with what we've just worked out, which is 2 cosec 2 theta being equal to 1. In other words, cosec 2 theta is a half. Now, we know more about the reciprocal of this. So this means that sine 2 theta is equal to 2. And we just need an explanation to say, but sine 2 theta is between -1 and 1. So it has no real solutions for being equal to 2. Okay? You could start from the right-hand side. I think you would find it a lot harder to know where to go with this. It's always best, well, I would say 95% of the time, I would start on the side where there are two things to get it to one, because you're taking two and merging them together. When you have one and you're trying to pull it apart, you don't really know which kind of way you're going to try and pull this stuff apart. What else have we got here? Let's do an implicit differentiation to finish off with. I can't do the 2023 papers. They're still locked on the website, which is kind of ridiculous. So let me find an implicit one, and then that will take us up to 6 o'clock. And I need to get my rest before the exams and stuff tomorrow. And I've got to do I'm revising for my further maths exams as well. I've got a horrible day on the 24th of June where I have got 4 maths exams back to back. That one I've done a million times. That's also in one of my videos, so I'm not going to do that. Now, I'm kind of tempted to do one of those. Let's see if I can find a better implicit kind of one. Should we do this to finish off with? No, that's going to take too long. This is going to take too long, but we're going to do it. Or I think we are going to have to do that one that I just said, but it is a long question. So I'll go as quick as I possibly can on this one, okay? So we have an implicit question that we have. Yeah, there is a session for further stats. It's already happened, but you can get the recording on that. But I haven't reduced the price on that, I'm afraid, because that one took me a long time to plan and it's very specialist. So that one won't be having a price reduction. So we have this equation, which is px cubed plus qxy plus 3y squared is 26. And we're going to show that this is how it differentiates. Now, this is quite easy to do the first part because we're all doing it with respect to x. I'm going to pull the power down. And I'm going to reduce the power by 1. Now, when I see this, I want to do it with the quotient rule, not the quotient rule, the product rule. And I would recommend just doing this, even if you do further maths, because it's quite easy to drop these marks. So when I differentiate qx, it just goes to q. And when I differentiate y, it literally goes to dy by dx. Okay, you know you do that with implicit. You have to add in that dy by dx, but just remember y goes to dy by dx. So for the product rule, we get a qy plus a qx dy dx. And then when we differentiate 3y squared, I will pull the power down and reduce the power by 1. But because it was y, it gets multiplied by dy by dx. And 26 differentiates to a 0 that we have here. Okay? Yep, this video gets posted afterwards, so you don't have to worry about any of that stuff. All I need to do now is make dy by dx the subject. So I am going to just factorize this dy by dx that we've got here so that I have dy by dx qx plus 6y, and I'm going to put this stuff onto the other side, which is minus 3px squared minus qy, and then on the next line I would be dividing it, so I'm going to do that here. Dy by dx is therefore equal to qx plus 6y over minus, that's completely wrong, I've flipped them around for some reason, so we get our 3px squared minus qy over qx plus 6y. So you can see it in the comparisons that we've got here that the value of a is the thing that goes with the px squared, so a is minus 3, the value of b is minus 1, and the value of c is the one that goes with y, which is just 6 that we've got at this point. So then we've got, given that the point P is 1, minus 1 minus 4 lies on C, and the normal has this equation, find the value of P and the value of Q. Okay, well that first one is literally just telling us something about the original equation. If it says that P is minus 1 minus 4, I know that X is equal to minus 1 and Y is equal to minus 4, and I'm going to put it straight into this equation. I'm going to go fast here because I'm running out of time. And remember, you can always watch this again afterwards if there's some things you need repeated. So I'm going to sub in minus 1 to this. That would just give me minus p. And then I'm going to do x times y, which is 4, and I'm going to times it by q. And then I'm going to do 3 times y squared. Well, y squared is 16, and I times that by 3, and I get 48. And that's equal to 26. So minus p plus 4q is equal to 26 minus 48, which is minus 22. That's my first equation that I have here. Now, my second one is to do with a normal. So I'm going to have to now figure out how to find the normal, and it's the normal at the point P. So I'm going to find dy by dx at P. So I'm going to use this equation that I already have. I would say that dy by dx is equal to minus 3p multiplied by x squared, which is just 1. I then have minus q multiplied by y, so that's a minus q times a minus 4. That is a 4 multiplied by q. And then the denominator is q multiplied by x, which is minus x, and 6 multiplied by y, which is minus 24. Now, I can find out what the gradient of the normal is because it's going to be the negative reciprocal. So the normal gradient is going to be the reciprocal. So we'll have the minus 3p and the 4 multiplied by q. That will be on the top, and I'm going to make it negative, so it becomes an x plus 24. Now, because I'm going quite fast here, I'm going to look at this other equation that they've told us, which was the normal. So it's our 19x plus 26y plus 123 equals 0. I'm going to make y equal to the subject. Why have I still got an x here? Why have I still got an x? That was not what I meant to have. That's not supposed to be an x, is it? What is it supposed to be? It's supposed to be a minus q. So that is supposed to be a q that we have. My mistake. I'm going to make y the subject very quickly. I'm just going to find out it would be a y equals minus 19x over 26. So that means that this must be equal to minus 19 over 26. That's the gradient of the normal, and this is also the gradient of the normal. So my final thing is to multiply up. I get the 26 times by the q plus 24 is equal to the minus 19 multiplied by the minus 3p plus the 4 times the q that we have, 26q. I'm sure this one's going to finish off with a mistake because this looks horrible. 19 times 3, that's 57p. And then we have a minus 19 times 4, that's minus 76q. So putting this all on one side, we get 624 is equal to, it's going to be simultaneous equations with this green one up here. We have 57p, and we have minus 76 minus 26, which is minus 102q. So my last thing is to find my graphics calculator. Oh, maybe I haven't done something wrong with this. I don't think I have. Okay, I'm going to just do the simultaneous equations with this green one and this red one. The pressure of doing maths in front of lots of people. Simultaneous with 2. Minus 1, 4, and minus 22. 57 minus 102 and 624. I don't think I did it wrong. I think I've got some lovely answers here. So P is 2 and Q is minus 5. And I just did simultaneous equations on the calc. Oh. I didn't need the gradient of the tangent. It was the normal that they were looking for. So that's why I took the negative reciprocal. Now, I haven't even checked my answer, but I do have the 2 and the minus 5. Gosh, doing maths in front of a lot of people can be very stressful. So I just wanted to say thank you so much for supporting me all across this year. I will be doing a reaction video after the exam paper tomorrow. Yeah, just come and see that reaction video, see what I thought of the paper. Did it have all of the predictions that I think are the likely topics to be coming up in that in-between session? If you missed it at the beginning, there are reduced prices on the mechanics and stats classes that have already run. As soon as you buy those, you get all the information in a confirmation email. If you want to come along to the in-between session, I did that at the weekend. You can download it right now and start using it. You've got about 4 hours of content. If you start now and have a little break for dinner, you can do that, go to bed, do the rest of it in the morning, and you'll be fine with that, okay? What else did I want to say? Integration, if you're stuck on integration, I've got a masterclass on topics on that as well. That's only a tenner. But I'm only doing that just because I want to be able to offer people some of those things at a cheaper price from before. So just wishing you the best of luck. I would love to hear how it goes after the paper. I always do a poll after the paper is done, so you can vote and tell me what you think before I do my reaction video as well. And yeah, I will upload this revised version of this exam question document. I'll put it in my Google Drive, and it will be linked in the description of this video as well, so that you can find it. I'll do that as soon as I log off from this live stream. I've loved doing these live streams. If I hope no one was unkind to anyone in the chat, because that's something that I really don't stand for. I can't see everything that's going in the chat all of the time, but I hope everybody has been kind to everyone, because ultimately we all just want to do our best. We've come along to watch a YouTube video to kind of to learn maths. Like, don't come along to be unkind to people, because we just want the best for everyone. Okay, so I'm just wishing you the best for your exams, and I'll see you in another live stream. I probably will be doing one on mechanics and stats. Mechanics is my favorite, so hopefully I'll have some good tips for you guys there. Have a good one, and I'll see you